Right. So, let us start the today's units. Today's unit formally. So it has two learning outcomes. One is understand the role of methodologies in the software development, and two is the be able to design an information system using a software development methodology. So in the same way, by looking at the indicative content and learning outcomes, so in LO1, it is asking you to explore everything, yeah. And then in the activity 2 and the LO2, you are being asked to choose one of the methodology and use it and give advantages and disadvantages. Then you are done. Yeah.
Okay.
Okay. So let us start some of the core indicative contents. Yeah. So that we should be able to discuss. And on last Thursday, Patrick, we had a very good discussion with Ray that what the software development is, and why we need the methodologies. So I would be some of the things I would be repeating some of the things, so that they would be for the revision for the Ray as well, right, Ray?
Yep, that's good.
Okay. So the aim is the learner will learn about the software development methodologies to develop an information system. So literally, the software development is basically the process of developing a software, and basically that's also called the software engineering. Yeah. So software engineering through phases in an orderly way. And like I discussed last time with the Ray, that how the software engineering came into the existence. Basically, initially the computer used to be the standalone applications, and people used to write the softwares into small programming languages. Those were limited to the one computer or standalone computers. Yeah. And hardly one or two programmers used to work on the software development, and it was very easy for them to communicate with each other and decide what to do first and what to do next. And eventually, again, they used to work on a single computer program. There were no any modular programming, so that the programmers could work independently and they could integrate remotely. Yeah. Then what happened? The introduction of distributed computing. Distributed computing, in a sense, the computer programs which could be run on more than one computer, and get connected with each other and made a part of a kind of distributed application. Yeah. So that distributed application, after the internet and the introduction of the internet, allowed the different applications to be deployed on many computers. Yeah. So it's not only the talk of internet, because on the internet, when you say, it's also a kind of distributed computing, but most of the time the server is the main computer and client is only the user. Yeah.
Yeah.
So client is the only user, and when it comes to the distributed application, then the distributed application will have terminals equally being the part of the software or the system. Yeah.
Yeah.
Individual terminals could become the parts of the software or system. However, if you are just using the browser, then you are not the part of the system. So each contribution, for example, within an organization, the accounts department, the different process, the, let's say, HR department, the production department, different departments, they could be the, let's say, major components of the system, and they work like, there is some background noise. Can you please make sure that something is, hello?
I'm on mute.
Hello?
Hello, yeah, right. Can you double confirm you can hear me very clearly?
Yeah, I can, yeah.
Okay, that's fine. Yeah, there was a noise. I thought it's in a transmission, but okay. Do let me know if anything interrupts so that I should be able to repeat it. Yeah.
Okay, yeah.
Ray, so I'm again repeating that concept. I think you can recall from the previous discussion, isn't it?
Yes, that's right. I agree.
Yeah. So the distributed applications and the individual parts were the kind of what they call is tightly coupled system. Yeah, what they call a tightly coupled system. Then the nature of the applications gave the need for creating the methodologies accordingly. Then they advise, for example, the traditional software methods, developing methods, which were limited to only one computer, could be very easy. You get the requirements, then get the analyze it, then design it and implement it. Yeah. But when it comes to the a kind of distributed application, then it means the workload on the development was increased. Yeah. When the workload on the development was increased, it means you required more and more work needs to be done so that you could produce a powerful and reliable software according to the requirement. Then the idea of the development methodologies came in, that people thought, somebody said A is okay, is the process is good. Somebody said B process is good. Somebody said C process is good. Process is number of steps that how you would be carrying out. But again, none of the process was good enough for every type of software. Make sense? Because the nature of the software, depending on the nature of the software, you are supposed to select the methodology. Make sense?
Okay, yeah.
Yeah. So let us move further. So software development is a systematic development in an orderly way of developing a software, also called a software engineering. Yeah. And so it has, obviously you prepare you need a requirements, you should have an objectives. Yeah. And then you design code and confirm what has to be developed and whether you meet the objectives or not. Yeah. So if you look at now every time we talk about the development, yeah, so development is also considered as a system development life cycle. Yeah. So the process comes through the life cycle. Yeah? And the system development life cycle is basically a kind of system engineering or information systems or software engineering term, basically, for creating, planning, testing, deploying a system. Yeah. So let us see that what is included in the system development life cycle. Yeah. So literally there are 4 phases of every software development process: requirement, design, program, implementation, and test. I think you should be very much clear from this. Yeah. So the requirement, like elicitation, you extract the requirement, analyze, specify, and system design is basically the analysis and design, and then program, implementation, and testing. but the major keywords of every software development are 4 of them. Do you agree? Do you agree?
Yes.
Yeah.
Yeah.
Yeah. But let us. But what happens? Depending on the methodology or more context, you could further extend those phases as well. Yeah, that I will discuss in the next slide. So let us see that what do you get in these 4 normal, processes. I think these are very basic, steps, and the things we are discussing, isn't it?
Yeah.
Yeah, but let us discuss, because we have to discuss each and everything in detail as per the requirement of the unit, and these are the things we have to discuss, and then we will be moving towards the advanced topics. Yeah. So in the requirement analysis, what you get a requirement specification. Normally you call it SRS, the software requirement specification, and you get use cases. Yeah. So can you quickly say, from the grammatical point of view, what do you say the use case? Can you give an alternative to the use case word?
Yeah, use case is like is like an example of what they would expect the system to do, based on a scenario. A use case is like a scenario.
Use case is a scenario.
Yeah, yeah.
Okay, if you okay, hold on for a minute, Patrick.
Yeah, it's like I guess an example.
Closely, but not exactly, Ray and Patrick. Use case is basically the verb. Yeah. And what happens in the scenario, you expect the verb and the nouns. Yeah. When you have a scenario, then in the scenario, you have a nouns and verbs, and according to those requirements, you extract the nouns and verbs, and the use cases becomes the verbs, and actors, let's say they become the nouns, and act those who act upon the particular action. Make sense?
Okay.
Yeah. So that's basically a little more detail about the use case. Yeah. So like a verb, what needs to be done, that's basically the a use case. And next in the design, yeah, let's say which actors will be doing it, nouns, then you should be able to represent into the design document or designing classes or objects. Yeah, is that clear?
Okay.
Yeah. So use case is a part of scenario, right? Then in implementation you have a code, and in the testing you have a test reports, and possibly the request for change. So these are the 4 things that fall under these 4 components. Yeah. And moreover, like I said, that these 4 of them could be further extended, like additional stage, like a planning, a project planning, and the feasibility study. Literally, if you include and mention this, it's good, but if you don't mention the feasibility or planning, and because if you assume that the project is feasible and it is already planned, like you have some resources, for example, the team that you require, the funds that you require, the resources, hardware, software that you require, they are already in place, isn't it? Yeah.
Okay.
So initially you can assume that you have already available, but That is an additional and extended stage that you should look for this. And in the second, you have a system analysis, or the requirement definition. Yeah. So at the system analysis level, you still define something, the actions that you require. Yeah. However, in the system design, you really identify the objects. Yeah. And you identify the classes like actors. Yeah. And who will be doing, and what would be effect on of the verb or the actions on other objects. Yeah. And obviously in the implementation, you code it, and then integration and testing, and maybe the sixth one is the deployment and acceptance, and maintenance is the seventh one. So literally, like I said earlier, that main are the 4, but the extended could be up to 7, isn't it? Makes sense?
Okay.
Yeah. So I think the words, they are self-explanatory, isn't it? So I should move further. Is it okay, right?
Yeah.
Yeah, that's great.
So analysis, design, implementation, integration, and acceptance, installation, deployment. Yeah. So these are normal. Now we come to the methods of software development, and what they are, and what is their nature. So traditional one and the agile project management. The traditional one concentrates on thorough upfront planning of the entire project, requires a high degree of predictability to be effective, while the agile one relies on incremental, iterative development cycles to complete less predictable projects, is ideal for exploratory projects. Simply, traditional one follow a path, a predefined path. Yeah. While the agile says it does not follow the predefined path, but remains adaptive according to the team and according to the interaction with the client. Yeah. So in traditional, you follow the sequence, you follow the path, a predefined path of the development, while in the agile development you adopt any path according to the team decision. Yeah. And the interaction with the client, in simple words. Is that clear? Yeah.
Yes.
Yeah.
Yeah.
Yeah. So that's basically the main trick behind, because why at some point the traditional methods, yeah, they force you to remain on a systematic way, but it is always time consuming. Yeah. And every time the requirements, in most of the cases, the requirements do not they are not available fully. Yeah. So that's why the traditional approaches are not helpful. Make sense?
Okay. Yeah.
Yeah. So let us move little bit further. So like a traditional, designing upfront, fixed scope, deliverables are guaranteed, freeze design as early as possible, and low uncertainty, avoid change, low consumer interaction, conventional project teams. And in the agile, continuous design, flexible features requirements are given. However, in the traditional, you get a deliverable. Deliverable is a final product basically. Yeah. In the agile, you are delivering a feature by feature. For example, you can say at the moment the database creation feature is available. Yeah. In the next iteration, you could say the retrieval is available, and in the third phase, you could say the update feature is available. Yeah. Sometimes you can say, oh, the testing feature is not available, or you could skip the feature, but at least you would have a say about something that these features are completed. However, in the traditional one, you say, yes, this is complete because the requirements were complete. Make sense?
Okay.
Yeah. So freeze the design as late as possible. Yeah. So always welcoming the change, high uncertainty. It's a big, you would not be certain about the completion or the final output, but at least you would be working on the features. You welcome the change, and customer interaction is high. Yeah. And self-organized project team. So like I said, traditionally everything is predefined, the procedure in the agile, depending on the team. So if I take a 2 minute break and want to your feedback about the traditional and the agile one by one. First, do you want to say, Patrick, anything about it? Ray.
I think Patrick's lost.
Patrick is left because I asked the question, difficult question.
Okay. Yeah.
Yeah.
Sorry, could you repeat?
I mean, yeah, the question is, how do you see the distinction in between the traditional methods and agile methods?
Okay, so for me, the distinction is that the traditional methods are very linear and linear.
Yeah.
And the is very sequential.
Yeah.
Whereas the new methods, they're more iterative. They overlap, and you don't have to have a fixed design in place or requirements in place at the very beginning. You can you can iterate over so many sprints or cycles until you reach your product.
Yeah, true. Yeah, that's true. Yeah, and unfortunately, yeah, in nowadays, because people really need a kind of rapid application development. Yeah, they want to see the output instead of looking at the requirement. They really do not give a value on if someone is working on requirements very deeply, and then analysis, and the customer, I would say the customer want the a kind of progress, a visible progress, isn't it?
Yes.
And there's a one requirement, and another requirement, that getting and freezing the requirements in a requirement phase, it becomes very hard indeed.
Yes.
Yeah. Because the user itself, yeah, or anyone else cannot predict or judge that what would be the a change in the requirement, but at least it is advisable that you must uh, you know uh, start with something, and give something, and then keep on working into the iteration. So it is forcing you, yeah, to work slightly different from the traditional method. So that's a fact basically. And now in the area and the age we are, it is the need of the time, isn't it?
Yes.
Yeah. So that's why everybody would be talking about the, if you go to the software houses for the developments, they won't be asking you the questions about the traditional methods, but they would be asking you about the agile methods, and would be asking you the comparison and your experiences, isn't it?
Yes.
So, but it is more important that you can only choose the agile development if you know the traditional methods. Without knowing the traditional methods, you cannot, work on the agile methods. Do you agree?
Yes, completely agree. Yes, yeah.
Now,
So,
yeah.
yeah, sorry, I was just going to say, so my understanding is based on what I've experienced and what I've witnessed is that the new methods won't be used all the time, because in situations where you have a major transformation program, like a £500 million business transformation program that involves infrastructure and software. My understanding is in these types of projects that tends to follow more of a traditional approach than maybe an agile or iterative.
Yeah, that's true. And one more thing, that an agile development has a disadvantage as well. Yeah, that for you can only adopt the agile development when there is a team of 10, up to 10 or 9 developers. Yeah, but you cannot if you have a more team, yeah, more number of team members, then agile will not be the suitable, and then you will have to come to the traditional methods. But again, there is a variety into the traditional methods. Yeah, so that we will be trying to discuss now. So traditional methods, waterfall, yeah, and its problems, and then pure waterfall model, and V model is basically an extension into the waterfall model. Yeah. So what I have done, given a V model into the waterfall model, a type of water model, then prototyping model, and then there is a phase development. Phase development is basically the of two types. One is the incremental one, and another one is the iterative one. And within the iterative, there is a popular spiral model. You must have heard about it.
Yes, we covered that last week, I think. Yeah.
Yeah. So, and then agile methods, the most of the popular one, yeah, like RUP, Rational Unified Extreme Programming, and Scrum as well, and the DSDM, and Dynamic Software Development Method. Yeah. So let us discuss into the details. So I believe that the traditional one, in order to understand the traditional one, the more and more we can understand the traditional one, then agile is a piece of cake. You only need to give a sequence and the new terminology to the existing phases of the traditional system development, isn't it? Do you agree?
That's right. Yes.
So agile is a kind of rolling wave and scheduling project methodology. Simple. You use the iterations to develop the workable product that satisfies the customer and key stakeholders. Yeah. So instead of reading this, yeah, if we look at the simple definition, agile is kind of adaptive. You select the strategy. Yeah. So you select the strategy according to the team and the uh, you know uh, interaction of the clients. Yeah, Patrick, you can hear me? Can you hear me? Hello, Patrick. Hello. Hi, Patrick. Right. uh let the Patrick get connected fully, so let me continue. Yeah. So the advantages, I'm sorry, the I'm repeating the definitions again and again, but it is worth to repeat and memorize into the mind. Is that okay?
Yeah,
Right.
yeah, that's good.
Yeah.
Hello?
Yeah. So advantages we discussed, and the disadvantage is that you cannot use the agile for the long and bigger projects which exceed the number of teams. So the advantages like focus on customer value, iterative and incremental delivery, experimentation, adoption, self-organization. Now, limitation we discussed. So popular, we discussed like Scrum and DSDM and the RUP. Now, waterfall, you know very well. There is a waterfall. You freeze the requirements, yeah, and you keep on moving on the phases, uh, in a kind of water flow. You cannot go back, yeah.
That's correct, yes.
Now let me these are the conventional diagrams depending on the four important stages, and further some drawbacks, like a drawbacks is we discussed that you always cannot have the requirements fully available at the start of the project. Do you agree?
Yes.
Yeah. So now we come to the V model. Have you studied the V model before?
Yeah, I have used it once before in a previous job.
Okay. Yeah. So V model is also the an extension into the waterfall model. So what they say basically that on the left hand side, for example, you have a same four let's say stages: requirement, design, coding. Then what you need to do, if you are in the requirement analysis, yeah, then after reaching the program design, you keep on testing basically in parallel. At program design, you keep on unit and integration testing, yeah. In the system design, you keep on doing the system testing, yeah. And at the requirements, you do acceptance testing, yeah.
That's correct, yeah.
So this may not be the kind of real picture, in a V, but could be you, or let's say you could say a parallel one, isn't it?
That's right, yes.
Yeah. So they say like a V, but I would say like a parallel. That you keep on doing a parallel thing. So simply, in addition to the waterfall model, yeah, you uh, keep an additional task at every stage. Make sense?
Yes.
Okay. Now let us move little bit. There are some advantages and disadvantages, but I want to discuss. Uh, you know. Uh, Is it okay? I should skip, their advantages or disadvantages?
I'm okay if you want
Yeah,
to talk
because
about
the
it.
reason I want to discuss little bit more on these things, on the incremental and iterative indeed. Okay, let's simply the V model, a variation of waterfall model. Drawback has a similar drawbacks as a waterfall model. Simple. Yeah. Too simple may not reflect the software process accurately. Use of inefficient and ineffective techniques that can be the problem. And rigid link between the left side and the right hand side, acceptance testing, correspondence to the user requirement. Basically, one drawback is that every time the testing would be annoying. You understand? In the V model, whenever it comes to testing each and every phase again and again, but it could be difficult because you did a little increment and you are going to test it, and that it can interrupt your progress. That's a disadvantage. Yeah.
Yep.
Okay. Then there is another prototype model. what it does, it reduces the risk and uncertainty in the development as well as time and cost. Yeah. So it gives the online system and human computer interaction. What happens if you have a system requirements here, then after the system requirement, you work on a prototype of the requirement, then design and system, then test it. And in case if anything needs to be, uh, revised, yeah, then you introduced another prototype, another revised prototype. Yeah.
Yep, yep.
So simple one. Patrick, can you listen as well? I think he may have a microphone problem, but he will be okay to listen to the recordings. Yeah. So drawbacks of prototype model: not sufficient analysis, because you will not have sufficient opportunity to analyze the functionality and scalability, maintainability, many things, and user can misunderstand the prototype as well and the final product. Makes sense? Because the prototype that you produce initially, it might be very attractive for the customer, yeah, but at the end it may not be the expectations of the customer fully. Do you agree?
Yes, completely agree.
Yeah.
Yes.
Yeah, so that's a problem in the prototype model. Now, are you clear with the incremental and iterative?
Yes, yes.
So without looking at the picture, can you say something about the incremental and iterative?
Yeah. So incremental to me is like Lego. You're building pieces of the software to join together. Whereas so maybe you would do one module at a time, or whereas in iterative, if you had to, so for example, in incremental, if you had to design a user interface,
Yeah.
you would design the user interface and then the back end, then the what other objects needed to be created. Whereas iterative, you would start to create the login screen or the welcome screen, or you would just start doing things. So you would build it piece by piece,
Yeah.
as opposed to having a complete block or module ready to deliver.
Yeah. Yeah. Good. And in iterative?
Yeah, so iterative would be more you wouldn't build blocks or modules. You would actually build maybe components or pieces of a module, and until you got your module created.
Yeah. Yeah, that's good. Yeah. So in incremental, for example, your software is depending on, for example, based on 100 modules. Yeah. A module is a kind of synonym to the function. Yeah. Function, module, procedure in the programming sense. Yeah. For example, so if you took one, one component for the programming, you complete it, and then you move to the another component, and then you move to the furthermore. However, in the iterative, you, for example, give an initialization of the code. You open the code and you create a boundary. For example, if you have to code the 10 functions, then you give the names to the 10 functions. Then you keep on adding the code one by one, and by slowly into each module. Yeah, like this. Here, in from the left to right, in the incremental, this block is done, then another block is added, and the third block is added. However, in the iterative, initially the three blank blocks are created first, then the first bar over here in the middle is completed, then the the second one is completed, and then consequently the other one gets completed. Yeah.
Yes, that's correct.
Yeah. So incremental model, yeah. What happens in the incremental model, if you could look at the picture, the requirements are outlined. They are splitted into increments. So you decide that what increments you will be doing, like a what uh, individual components you would be working on. Yeah. Then you would design the system architecture accordingly. Yeah. But
Yep.
when you enter that into the development, yeah, you would implement the particular increment only, and then you would validate that increment, then integrate that increment, and then would validate into the whole system, and then you would be into the loop. Yeah. Loop
Yep.
for the another increment, and then you would get a final system. Yeah. So that's basically the incremental. And furthermore, if in the increment one you selected 4 components, and then in the another incremented you did a little bit more work on every increment. Yeah. And not every increment, but you got another increment, and you got third increment in overall. Yeah, because the incremental is that you are keep on adding the new components. Yeah.
Yep, that's correct.
Yeah. So maybe there could be a different colors of these new increments instead of same. Yeah.
Yes, that's correct. Yep.
Yeah. Then some advantages of the increment, that it's a early utilization. Early increments can serve as a prototype, lower risk of overall project failure, and then most crucial and basic services are implemented first, receives multiple testing throughout development. Yeah. And then problems, hard to map requirements into small increments, less than 20,000 of course. So basically, if you want to work on, let's say, module by module, yeah, then at some stage you could know that which components needs to be implemented first somehow. Yeah. But it would not be always easy to know that which components are uh, important, and maybe, for example, you spent your 50% time on very simple basic modules, and you realize that without certain modules you cannot proceed further, isn't it?
That's correct. Yes.
However, if it was the iterative one, then in iterative one, every component should have been given an iteration and addition into the work. Yeah. So
Yes.
hard to define the basic services that are shared by all subsequent increments. So it would be not useful and to identify that which are important. Yeah. That's why, yeah, the iterative one, helps you to work on the iterations, and the Boyens spiral model is one of the iterative model, and it works into, let's say, in this kind of spiral. Yeah. So in iteration, let's say, for example, you determine the goals and alternatives, then you move on to the next phase, evaluate alternatives and risks, and then develop and test and plan again further. Yeah. So this model comes under the iterative model, and what the iterative does is very much understandable into this picture. Yeah.
Yep.
Yeah, I think you should be okay with this idea, and it's not necessary that we should go further into the spiral, more into the detail. Yeah. but the idea is very clear, I hope.
Yeah, we covered that last week, so I'm okay with that.
Yeah. And then if we come to the agile development, yeah, then the agile development has traditional methods like agile development has the advanced methods, which is the extreme programming, RUP, and DSDM. So let us have a look on them. The extreme programming, yeah. So we'll discuss three of them here. So in the extreme programming, the phases have been given this sequence, like exploration phase, then the planning phase, then iterations to release the phases, yeah, and then the product ionizing phase, and then maintenance and the death phase, yeah. So somehow these customer approvals are basically, you could see the arrows from the planning to the small releases. Are you able to see?
Yes, I see that. Yeah.
So that's basically the extreme programming, and certain phases, like I said, that every system development has these four phases. So they have given the names to these phases, like exploration phase, planning phase, then iterations to release the phase, the product ionizing phase, and this is basically the system is ready for the first release, yeah, and maintenance and death phase. Yeah, that's a strange phase name, isn't it?
Yes, it is actually.
Yeah. So at this stage we can only read and get an idea of the number of phases. Yeah. And should I move to the next methodology? Yeah.
No,
So
that's
advantages, XP is an iterative development method. Yeah. So it's not the case, yeah, that the agile development has got their own way of doing, but they are sometime at iterative, they are sometime at incremental, isn't it?
yes.
So their pros are here, and the cons: lightweight on process side. Yeah. So lightweight is basically that your strategy is flexible, but it does not support. Yeah. And heavyweight is these are the topics, heavyweight and lightweight, that we will be discussing into the next LO. Yeah. So but lightweight and heavyweight, they are the planning basically. Yeah. That you do work hard on the heavyweight, like in the traditional one, and XP is as has a disadvantage, that's a lightweight, and then trust the developer. Yeah. Customer makes business decisions, the continual process improvement, not tied to expensive tools, and development makes technical decisions, and on the other side does not specify the artifact, lot of customer involvement, perceptions that it is organized hacking, does not have a lot of tools. So next one is the DSDM, and it has this picture of process. Yeah.
Yes.
And so it starts from the feasibility and the business study, then moves to the functional model iteration, and from functional model iteration it comes to the design and build, and from the implementation it can come back to the design again. Yeah. And it can give a feedback to the functional model iteration, and it can give the feedback to the feasibility as well. Yeah.
Yes.
Last and the third and the last is the rational unified process. Into this there is an inception, elaboration, construction, and transition. Yeah. So inception is like same as the requirements analysis. Yeah. Elaboration is the design, and construction is the coding, and transition is the testing and delivery. Yeah.
Yeah.
So like I said, that RUP is the process advised by the three writers, Greedy Bush, Ramba, Jacobson, and UML distilled is the software. Oh, sorry, the UML distilled is one of the book. And sorry, I couldn't upload all of the books that I referred, but I have the available at the moment. Let me show you. Yeah. So the books of the software development I would right away send to the module developer, and they would upload as soon as possible. Is that okay? Yeah.
Yeah, that's great, because you mentioned the one to do with Somerville as being a very good one. So I think Raman's uploaded some, but not all.
Yes, there was a little misunderstanding. The Samit thought that Raman has already, I asked today from Samit. He said that Raman has, uploaded, but when I seen that those were not uploaded, all of them, but I would send, these to Samit, and he would upload, straight away tomorrow, hopefully. Yeah. So these are one of the recommended books. Yeah. Let me show you. Like these recommended books, and the red one, they are not available, but those which are in black, yeah, so should be available for you to study. Yeah.
Okay, that's great.
Yeah. And in addition to these books, yeah, I would also include a kind of textbook of the software engineering by Ian Somerville, yeah, and a book on the UML distilled, yeah, which is the written by Greedy Bush, Ramba, and Jacobson. And for your information, the UML distilled book, yeah, explain A to Z about the RUP, yeah,
Yeah.
RUP, and RUP has got a certification available as well, yeah, which is the OOAD, yeah, object oriented analysis and design certification, which is worldwide recognizable. Yeah.
Okay, yeah, that's good, because I would like to professionally have a standard that's good.
Yeah. So that certification is available, and as I remember that ages ago, like 10 years, when I used to study Java at uni level, then those certifications were available in the object-oriented analysis and design, and that is purely from the UML and especially the RUP method. Yeah. And only that particular book, UML distilled, yeah, uh, was sufficient to pass that certification. Yeah.
Okay, that's good to know.
Yeah. So after passing this certification, you can definitely work as a system analyst on the higher position.
Okay, that's good to know.
Yeah. And I think that's the certification from IBM or Sun Microsystem. I'm not sure. But object on, we can have a look right now. Yeah. So it would be an additional, thing for you. Yeah, IBM. Yeah, that's the IBM certification, and that's OOAD and UML training, and then you get the certification, and then there is a additional some of the topics which are from design. Yeah, and there is a book for the design pattern. So what you need to do, you need to understand the UML, yeah, and the study the RUP and design pattern like MVC. Have you heard about the MVC?
No, I haven't actually.
Yeah, that's a model view controller.
Okay.
Yeah, there's a model view controller, and basically they give a kind of the tiers of the application. Yeah, in the MVC there's a 3-tier application. Yeah, the at the it's one of the pattern which is used into the for example particular methodology, but there could be business logic as well and more patterns as well. Yeah.
Yep.
So you can look at the syllabus of the certification. Yeah, and that's really good, and try it, and we can discuss on this next time.
Yeah. No, that's good.
Yeah.
Yeah.
So we are almost done for this, and there was a RUP process, and it has had these number of stages, and then DSDM, then XP stages, and overall the methodology, the 4 components, and then there are the variations and advantages and disadvantages. Yeah.
Sorry. I've just recognised I've left my charger, my laptop charger at work, and my battery's just about to die.
Okay.
So yeah, I'm going to have to end it here. Sorry, Ajay.
Yeah, that's fine. I'm already done. So I was just recalling. Yeah, that's fine. See you soon. Yeah, see you next week. Yeah.
Okay.
All right.
Thank you very much. Thanks for your
No
time.
problem.
Thank you.
Thank you. Bye. Bye. Bye.